Alright, welcome everyone. Today we're going to go through and show you how we can use the likes of something called subroutines and functions, which is the next of our level 2 concepts, to make our programs more robust, more flexible, and also to cut down on the amount of code that we might like to look at using. So there's a couple of ways of us being able to go think about what a subroutine does. Within Visual Basic, we use the term subroutine to mean any kind of block of code that we can call upon to do a job. And it will just go away and do that job. We can pass it a couple of things to do that job that's needed, but nothing's returned back to the main program that called it. So the main program that's called it is within this area here called submain, which is always the natural entry point for the start of the compiler in the program. When it hits the block of code that tells it to go somewhere else, it will jump down to the block of code that it's being asked to perform. It will perform the block of code, and then it will come back up to the submain. So an example that we might like to use for this one here is, say, the use of an input subroutine. With a subroutine, the way that we go through and declare how we're going to use it is we simply go through and we use capital letters to indicate the fact that it is a subroutine or a function that we're looking to call. This is called Pascal notation, and it's a convention that we'll use here at school. And we'll also notice that the fact that we've got these rounded parentheses after the term input is indicating that we are calling a subroutine or a function. The difference between a subroutine and a function is a function will always return something back to the main program that's called it. So for instance, if we're wanting to go through and validate something, we would need to go through and call this function that is going to go through and do the validation steps, and at the end of the validation steps it would return a number that is maybe considered valid or invalid back to the main routine that called it. So let's go through and take a look at this input subroutine that I'm going to try and work with first. So rather than me trying to make my main code here get quite long and unwieldy like we've done to this point, we really want to try and break up our code up into logical little blocks. So for instance, if we thought of a program which is wanting to get an input from the user, and then maybe we're wanting to do some kind of validation on that from the user, and then maybe wanting to do some kind of calculation on the work that's come from the user, and then maybe towards the end we're wanting to then output something from the user. We could go through, and rather than putting all of our code inside the main routine, we could go through and make a logical kind of decomposition or breakup of the program, is what they call it, by saying, look, we know we need to input, but I haven't quite thought about all the ins and outs and the logic behind it yet. I know that after I've got that input, I'm going to have to try and validate it. I know then that I have to go through and do some kind of calculation on it, and then finally I need to go through and output the results of all of the items that have been popped through. And then all the fleshing out and the detail within our code is simply going to be performed further down the track here. So for instance, if we would go through and show you how the flow of our program has now changed, I'll go through here and place a couple of inputs on here, and if I was to copy and paste this a couple of times, and I'm simply going to be altering these slightly just so you can see the fact that what's actually happening is the code is jumping backwards and forwards between all these new subroutines that I've been writing. Okay, so I'll put breakpoints on each of these. So this is probably something that's going to be quite different. Normally we've just put a breakpoint on the one subroutine that we've been working on, and you'll see the flow of the program. Because, however, it is jumping backwards and forwards between all of these different items, we're not going to see any of those things happening without breakpoints on each of these different subroutines. So here's an example. It's going to go through and do all of these 4 statements here, which is going to be outputting the likes of hello world each time, every time that it gets these lines of code. Only time that we'll see the pause is when it gets to this step here. Okay, so if I was just to push the F10 key, it's going to go through, and you may be able to see this with the fact that different lines of codes have been triggered underneath, but it's not that obvious. But look, there's the likes of the hello world being repeated 4 different times. If I was to go through and then make this a little bit more obvious, I'll say that it's going to be a hello world from each of these items. Okay, and if I was to go through and put a breakpoint on these now, you'll see the flow of the program operating a bit better. Okay, so at the moment it's now looking at the input. It's going to hit this line of code, and after it's operated or run through this line, it will know to jump to this subroutine called input. And so here you can see the yellow arrow is now indicating that this is the line of code that it's up to. If I was to step through this code here, it's going to run through the subroutine from start to finish. As soon as it hits the end sub, the flow of the program will then come back up to the top here and then continue down to the next line. Okay, so now it's going to be calling the validation subroutine, perform that, outputting, and then we'll pop down to the calculation, and so on and so on, all the way through until each of the subroutines have been called, and then finally our read line is occurring. So I like to think of the analogy for this is that if I'm wanting to go through and paint a house, I'm going to go through and ask you to basically do a job for me. You're going to get the job done, and then nothing's returned back to me. Obviously you know what to do in terms of the instructions, so the input, this series of instructions would become quite a lot more detailed. The validation would become a lot more detailed in terms of checking numbers and making sure ranges are okay. Calculation, this could be many lines of code here to do some kind of amazing calculations. And then outputting is something where we might want to be outputting the items of a list, etc. Now let's go through and try and show some of the more intricate things of this. In order to do its job, such as the painting analogy I said before, sometimes we have to give you items to be able to do your job properly. So if I was to ask you to paint my house, I'd need to give you some paint, I'd need to give you some paint brushes, maybe some sanding blocks, etc. So therefore, if I need to do something by handing you off something, I can go through and indicate what it is I need to get the job done through the likes of these brackets. So with my input function, all I'm going to do in this program is actually ask the user for an input. Okay, so please type in your input. Next thing that we might want to try and do here is to remember what item is being displayed. So at the moment, this is going to output, ask the question here, please type in your input. If we're wanting to assign something, we need to be careful about where we declare the variable, because any item that's declared inside of a subroutine is only available inside of this particular subroutine. If we're wanting other things to be available to it, we either need to pass it off to another item or another subroutine, or we need to declare our variables in a slightly different way. So the first thing that I'm going to try and show you now is where we declare our variables. So if we choose to declare it above our submain or above one of our subroutines, it means that it is going to be considered class scope or module scope variables, which means that any of these subroutines or functions within our program can call upon, use, and update this variable. So for instance, if I was having, say, a age variable that I'd like to try and deal with, and it's an integer, by declaring it outside of the submain, you'll notice that a little line here has occurred. This is trying to show you the fact that any item within my program can now use it and access it and update it. So for instance, if I was wanting to go through and do that, if it was to go through and please type in your input, I can update the age now to be 200. Or I might pop down the bottom here and make it now -11. The problem with this is that it becomes a little bit dangerous, because everyone can use this, everything can update it, and everyone can override each other. So for instance, if I wanted the number to be 200, to go through and pop through this program now, you will see that the item age is storing 200, but under the next block of code here, or when it gets the calculation block, it's going to be overwriting that 200 with the likes of a -11. Okay, so here it is, it's now up to the calculation step. Age at the moment is still showing as 200 from our previous steps. Stepping through the code here now, we've now overwritten the likes of age, and it's now showing as -11. So there are some risks in terms of us declaring some of these variables outside of the scope of our main procedures. So generally it's kind of frowned upon to do that. One of the things that we can use outside of the subroutine quite easily is the use of constants. Constants are like variables, except they don't change, so not really like variables at all. They're items that are set and can't be changed through the running of the program. They have to be hard-coded in. So a good example of that would be the likes of GST. GST is a hard-coded number because of the fact that the government sets it, and it's set currently at 15%. But if another government got in and decided that they would like to raise or lower GST, rather than us going through and updating all of our code throughout, we're simply going to come through here and update the item, as you can see, through our code. So if I was to go through and assign this correctly, you'll see that it's storing this as 15%. Any bit of code that's wanting to be able to use it, it can use it fine because it's considered a module level or class level constant, but no one can update this because nothing can update a constant. It's only really the programmer that can come through here and choose to perhaps take this back to say 12.5%. Let me show you an example of that. If I was to try and update what GST is, if I was to say let's put it back to 17%, you'll notice here constant cannot be the target of an assignment. So I'm getting a little error message to try and help us along the way here. Okay, so we can decide to declare variables up here, but it's not always that safe. So another thing that we can do with the likes of subroutines and functions is we can declare the likes of these variables inside of these subroutines inside of the main body of our code, and then if our subroutines needs this variable, we can go about looking to pass this variable across into the subroutine. Now, in order for this to work correctly, we need to go through, and normally we do it here. We actually tell it in the subroutine that we write, what is it that we need in order to get the job done. So we probably don't want to be asking them to type in the input here and declaring it like so. This is probably more relevant for the likes of some kind of function, because something would be returned back. But say we're wanting to do maybe an age calculation or a number calculation. Maybe we'd like to have some numbers added together. So let's go through and do an example that you may well have done in class, which is we'll give num1, which is 20, and we'll do num2 a value of 10. And what we'd like to do here is pass this subroutine these two items from above. And what we'd like it to do is we'd like it to go through and do a calculation. And the calculation could be adding, subtracting, dividing, doesn't really matter. In order for this to work correctly, we're going to need another variable. And the variable is going to get loaded into the bottom here. So this can be a little bit confusing when we come through here, so I will aim to explain this as best as I can. Okay, so what we're going to try and do here is we'd like to call this subroutine called input. In order for input to do its job, it's going to need two things. It's going to need num1 from above here and num2 from above. So what happens is that these items that you can see plugged into these brackets are called parameters. These parameters will get passed down into this subroutine down the bottom here as something called arguments. I'll just call them parameters from now on at either end, just for keeping things simple. However, the items that get passed down here can be passed one of two ways. We can pass things either by reference or by value. If we pass them by value, it means that we're actually not operating with these original values, but rather a copy. And this is probably the method that I prefer. I actually don't want to mess with these original numbers. I will simply be working with some copies of those numbers that are being passed down to it. So through the likes of my code here, I'm going to be calling them num1 copy and num2 copy. If I was to show you the running of this program now and how this might be operating, saying age is not declared, I'll just delete this code out and try again. Alright, so here it is, it's got age, we've declared it but we couldn't use it. Popping on through. Okay, so this is where we've now got num1, which has been assigned on a couple of lines above as being 20, and we've got num2 as being 10. The flow of the program now is going to call the input subroutine. It will then pass these two numbers of num1 down into this argument here. So this num1 copy is ready and waiting for an integer to be loaded up into it. So push F10, here it comes. So down the bottom here, it's now received this value from this main routine. num2 is now storing this value of 10. It's important to note, however, that both of these have been passed by val. Because they are by val, they are only copies. If I was to use the other item that you saw in that list there, which is called by ref means that you are updating and dealing with the actual values. So for this instance, I can actually choose to not use the copy of it. I can still call it whatever I want, but I am actually updating this item that's been passed down. Okay, so if I'm wanting to be able to update, say, the second version that comes down, or this item here, I can pass it by reference. If I pass it by value, I am not able to update the original data, just the data that's been passed down to me. So that's where it's a bit of a confusing concept, is knowing that we can either update the original stuff or work with a copy of it. I tend to always work with copies of things, so I'm going to stick with by val. And under here I'm going to declare a new variable called dimtotal, and this is going to be an integer calculation that we're going to perform. So I'll just go through and output now these items. Okay, so in here we will make total equal to num1 copy plus num2 copy, and then outputting this, we're simply going to go through and put the total is equal to, and then we can output or concatenate on the likes of our total. Okay, so the number 20 and the number 10 are passed down to our subroutine. It's ready and waiting for these integers to be delivered to it. It will then declare another variable called total, which will store that 10 and 20 being added onto it and then outputted through the list here. Okay, so if I was to go through and take out these other items, so we'll see how the program will actually flow. Okay, so it's this line of code here at the moment. Go F10 and step through my code, num1, num2, pass it on down to the subroutine. Here it is, they've been loaded up with these values. Total at the moment storing 0, but after this line of code now, total gets updated to shows 30. So 20 plus 10, hold that as 30, output that back to the console, then go through, finish this off, give me a read line, and output that back to the console. So that's effectively how a subroutine can work. Now the great thing with subroutines is these items that have been plugged in here, we can actually make subroutines which are quite smart. So what if we didn't want to just pass it 2 numbers? What if we wanted to pass it 3 numbers? So maybe we had 3 numbers that we were wanting to give it. Okay, so we'll give it num3. And if we give it a third num, and we'll make this one worth 30. So at the moment it doesn't really know what to do with itself because it's getting confused. It's saying, hey look, I've got 3 parameters here, but I've only got the availability for me to be able to place it into 2 of them. What I'm going to do now is I'm going to copy and paste this subroutine directly underneath each other, and instead of only having 2 arguments ready for it to be received, I'm going to go through and make a third one. Okay, so next thing that I'm wanting to do is maybe I'm wanting to work with these two numbers. So we could have what's 20 plus 10, and then maybe we're going to subtract 30 off the end of it. Okay, so in this second subroutine called input, so they've both been given the same name, I'm going to ask it to let's take away num3 copy, which should make it back to 0. So let's make that a bit more interesting. Let's give this a higher value. Okay, so 20 plus 10, that's going to be our 30, 30 minus 90, so we should end up with negative 60 if this has worked correctly. So for this, because we've now got 3 items being worked out here, if I was just to go through and plug it through, it'll be smart enough to know which one it should call upon. Because of the fact that we've got 2 items here to begin with, it will go through, look at calling this one first, and then it will realize I can call this next one. Well, we already know what happens if we've got 2 items. It will go through and call this. I'm going to just go through and just blank this one out. Okay, so I've just gone through and commented that out, just so you can see what happens. I've now got 2 subroutines, one that can handle two arguments and one that can handle 3. So because this one's got 3, it will know that it's going to jump down and find the subroutine that can handle the likes of 3 different parameters. Okay, so if we go through and try and test this out. Okay, so it's up to this block of code here now. I'll just put a breakpoint here. Push F10, which one does it select? It selects the one that actually can handle the likes of 3 parameters being passed to it. So down here, it's loading up and ready for num1 copy, num2 copy, num3 copy. Okay, so it will then go through and perform the calculations as outlined previously. Okay, so there's our negative 60 number being returned back to the console. Okay, so in terms of our program, this is actually getting a bit smarter in terms of maybe being able to do different things depending on what we'd like to call it. So this is where probably code robustness comes in the fact that our programs now maybe wanting to do different things based on different criteria being plugged in. So just tidy up this code a little bit, and the next thing that I'm going to look at is going through and just tidying things up a wee bit, and then start using the use of something called a function. Okay, so we've now gone through and shown you how we can call a subroutine by giving it certain things that it needs to do its job, and then the flow of the program is returned back and things continued on. Nothing is returned back to the flow of the program, however. The next concept is the use of a function. So a function is probably a more obvious way in which to use the input. What we'd like is we'd like to call a function called input, and if a item is being plugged in by the user into input, we'd like it returned back to the main program. Okay, so let's go through and we will look at commenting some of these blocks of code out, or potentially deleting them, because we're not going to be wanting to use them now for a little bit. And I'll just enter them down a bit. Okay, so I won't delete them because it is kind of like our notes, if you will. We don't have textbooks as such, so our notes are effectively what's happening in our code here. Okay, so let's go through and let's start up an input, and with this input to start with, I'd like it to be a string. This string could be anything that the user chooses to plug in. So for this input, we're going to, oh, actually that could be a bit confusing. Let's have the age, I should say, being plugged in, which I've done previously, but I've commented this out. Okay, so I'm going to work with a string because basically I want the user to be able to type in anything. I don't care what it is. Ideally I'd like it to be a number, but if it's not a number, I'm going to look at trying to deal with that further down the track. Okay, so down here I'm going to call an input, and I'm going to call a function, and it's just calling me this at the moment, but I will try and override that. Okay, so before we used the word sub to define the subroutine, and then we gave it the name. For here, I'm going to now use the key term function, and for this I will give it a term called input. Now for this, again, same story like a subroutine. I can pass it things it needs to do its job. So in terms of it being passed things, what I could do is I could reuse our code and basically give it down a string if I wanted to. So we might look at getting into that further down the track, but at this stage what I'd like to do is I'd like to tell it to jump to this block of code to do something and return something back to the subroutine that called it. So in here we're going to ask the user to please type in their age. And the main thing that we do here is with the likes of a function is that we always need to have a return statement in it. So a return statement is what is the item that will get sent back or returned to the code that called it. So this is the code that called it, the input and the brackets here. When this item gets returned back, something needs to remember what is returned back, and that's what the assignment statement here is going to do. So age is going to remember whatever is going to be plugged back. Okay, so age, which is a string, so it can handle anything that is happening, and the item that I need to go through and hand it back will be the likes of a console.readline. So I could easily have done this with the likes of a variable and returned the variable back. Okay, but I'm just wanting to show you now what's actually happening. Okay, so here I will now output the contents of the age. So same story as before. We'll show you how the flow of the program is now working. So when it gets to age at the moment contains nothing. Try and push F10, it will jump to the next block of code in terms of the function, and it will then output this statement here, please type in your age. It will ask the question. It is now going to remember what I type in. So if I type in a name, it will remember that, and it's going to return Peter up to the code that called it. Okay, so after this line of code, it's now remembering the term or string Peter. If I was to go through, rerun that, step through my code once more, and type in something valid, check to see how the flow of the program is running. It's now holding this string, and notice that it's a string because the likes have got quotation marks around things. That is holding the variable 16. Okay, and if I was to output this, it would simply output 16 back to the screen. Okay, so that could be the first way that we look at using some kind of called function. We're actually asking the user, in this case, to do an input. We haven't done anything else in terms of validating whether it's okay or not, or the right data type or within the correct range. That might be a separate function that goes through and does that, or it could be something that we embed within the code here. So that's probably a valid place for us to look at doing this now. How about in this code we go through and check out whether this is actually going to be valid or not. So in here I'm going to make another variable called valid input. Now this valid input, we are expecting it to be an integer, and I'll give it a value of 0 to start with. So we want them to go through and to be able to work out what they've plugged in, and to start off with we'll take whatever it is that they're wanting to deal with us. Okay, so if they're going to type in things here, we'll just chop this out a little bit, move this up, and we'll make our program a little bit smarter. Okay, so we can combine several of these lines together, but I'm just separating them out there for a little bit of clarity's sake. So whatever they type in, of course, will be stored in this input stuff, which is a string. And now I might choose to go through and do our try pass. So remember, there's several ways in which we can do a try pass. Okay, so with try pass we're going to take in this case, input stuff, so the string, so it could come directly from the console.readline if we wanted to, but as I said, I've tried to separate this out. if it can go through and take this input stuff, and if it is actually a valid integer, where would we like it to go? We would like it to go into this valid input variable that we've just created. Now this item here basically means if it can do it, it will do it, and it will send it off into this variable. If it can't do it, this will not be updated, so therefore it'll just be skipped and left as 0. So normally, rather than just doing it in this way, I would probably tend to wrap it with some kind of if statement, and this makes it quite obvious that if it can do it, then maybe I do some kind of message and then as part of that it will go through and also assign it. Okay, if it is not valid, however, I might like to go through and possibly say error. Okay, so at this stage it's gone through and plugged this all through. We've got this valid input. We can't really return that because if they actually typed in 0 or nothing, this will actually still be 0, and then that would be a return to the main program that called it. That might be okay if we're smart enough, or we have a bit of code in there which means that this will keep getting run until we get what we're after, but probably the likes of some kind of loop in here would be a better way of doing that. Okay, so we can actually keep prompting this to go round and round until we end up with something that is maybe not 0 and is not a and is something that can be passed across into an integer. Okay, so maybe that's something that we can look at doing now. So why don't we do that? Why don't we have valid input? While valid input is, could use something like not equal to 0. We could say while it's equal to 0, keep running it, because if it's equal to 0, it means it's not good enough in terms of, you know, being overwritten. Okay, and then we could just continue. Okay, there it is, just a bit of a mind blank there in terms of the code to use. But so once we have our while, we're going to finish off with our end while. So while valid input is equal to 0, it's going to keep going through and asking the person to type in their age. So we could go through and make that a different number, say going to be -1, but the problem with that is that if they type in something that's, say, a letter, this might not be overwriting it. But let's go through and just check that to see what's actually going to happen. Okay, so it's going to pop through here and maybe ask. It's just causing a little bit of an error because of the fact that when we have a function, it needs to return something. So I'm going to go through and put return valid input and try and run this now. Okay, so here is my valid inputs being set as -1, so this is going to be a little bit of a problem because valid input is not going to be equal to 0, so let's just tweak that a little bit first. Rerun this. And stepping through the code here, so while valid input is equal to 0, okay, which means they haven't typed in something that we like just yet, we're going to keep running this code. So here it is, please type in your age. If I type in a letter, that is invalid. If it can do this line, which it won't be able to do, okay, it's going to then pop through and say this, and therefore valid input will still be set to 0, which means our loop is still going to continue until I go through and plug in something that I like. Now if I type in an invalid age, such as a negative number, this is still something that can be try-passed or passed across into an integer, so my program is not smart enough to deal with that just yet. That would be the use of boundary checking. But if I was to type in something that was clearly invalid, it will go through and keep running this until a valid number has been plugged in. So let's go through and just plug this in. Let's plug in a correct number, And then now you'll notice that this next line of code is executed and valid input is now set to 30. Okay, so with this, the loop will then finish and it will go through and return this 30 back to the subroutine that called it. And now age is going to be changed after the next F10. Age is now going to be set to our 30. Now this 30 that's been popped through here, you'll see that it is a string, and that's because I was telling it that it had to be a string because I wasn't sure it was going to get plugged in. But because I've got them here, I'm now able to say, well, I know it's gone through that checking, so therefore I can change this to now an integer. Okay, so if it's gone through all this process here, it's definitely come back and it must be a valid integer. Now if I go through and do something like a net of 20, it is a valid integer, and if it will come back to my main program now. So I'd need to do a little bit more error checking and validation checking than that to make sure that I'm able to handle the likes of negative numbers. So that's something that I could do through the likes of our while loop, and that's something that's needed for the likes of Merit. Alright, but that's essentially how we can use a function. We can go through, we can ask the function to do some kind of calculation, and the main thing is that something will get returned back to the subroutine that called it. After the subroutine, I've now got an input, and with that input I may choose to call something else, such as maybe a calculation. So the calculation could be any of the ones that we've done to this point. We could work with our lists from previous, and we could basically go through and plug in salaries that we now know are valid. We could pass it off, for instance, the salary or age into the next calculation side of things, and the next side of things could be working with a list, and then we can pass different items down to it. So essentially that's going to be the likes of functions in a pretty brief kind of look at it. Obviously we can get more involved and do more with functions, and we'll aim to do that over the next little while. But functions are handy with the likes of subroutines, because if we were to go through and try and do this all within our main block of code, it's quickly going to make this quite complicated, and it's easy to break up our problem into small little chunks, if you will, by having lots of heavy going code further through our program rather than our main subroutine. So hopefully you found that helpful, and we'll try and recap and cover off some more of this in the future.